Hi, this is Julie Harland. Please visit my website at yourmathcal.com where I organize my videos by topic. A fraction that contains one or more fractions in either its numerator or denominator or both is called a complex fraction. Below are 5 examples of complex fractions. Complex fractions are not in simplified form, and there are 2 common methods for simplifying a complex fraction. In the first method, both the numerator and denominator need to be written as single fractions, and then you can multiply the numerator by the reciprocal of the denominator. In my example, the very first one is in that form, so method 1 works very well for that. For the rest of them, method 2 is actually easier for most people. You multiply the numerator and denominator of the complex fraction by the least common multiple of all the denominators of fractions in the numerator and denominator, and this eliminates the complex fraction in the first step. All right, in this example, we're going to use method 2 because there are 2 terms in both the numerator and denominator. So we need to look at the fractions and multiply by the least common multiple of the denominators. So remember, that means you've got whatever it is, each number will cancel into that. So if you have an x and an x squared, the least common multiple is x squared. You have to have at least an x squared to have the x squared cancel. So I'm going to multiply both the numerator and the denominator by x squared. So we have x squared times 3, which is 3x squared. It's going to be nothing to cancel there because it wasn't a fraction. The 3 was a whole number. And then we have minus x squared times 30 over x. Now, it doesn't matter if you write the x squared in front of the fraction or after it. Just to show you it doesn't make any difference, I'm going to write it as 30 over x times x squared. You could do it either way. And in the denominator, I have x squared times 1, which is x squared, minus x squared times 100 over x squared. Now, what's going to happen when I multiply that x squared times 100 over x squared? The x squares will completely cancel, and I'll have 100. If you want, you could write that step, but see if you can imagine what's going to happen when you multiply 100 over x squared times x squared. Right, now over here, though, I do have to pay attention. I have 30x squared over x, so we could cancel, and that'll leave us with 1 factor of x still in the numerator. So I have 3x squared minus, make sure you don't forget to put 30 times x, 30x over x squared minus 100. Right, so I did eliminate my fractions by multiplying by the least common multiple, right after I do my distributive property and reduce, I do get this, but I'm not done because you have to see if this fraction, which is not a complex fraction anymore, right? It's just a rational expression. You have to factor to see if anything cancels. So let's see. Out of the numerator, the least common multiple is 3x, so that gives you 3x times x minus 10. And in the denominator, this is a difference of 2 squares, so that's x plus 10 times x minus 10. And note, x minus 10 cancels, so we end up with 3x over x plus 10. By the way, you can always keep a parentheses around the binomials like x plus 10, but it's not necessary.